Hi everyone, welcome to this webinar on application observability. My name is Suresh Govindachetty. I work as a senior enterprise solutions engineer with Sumo. And in today's webinar, I'm going to walk you through how you can efficiently monitor your applications, troubleshoot it, etc. Before we get started, a couple of housekeeping stuff. There is a Q&A button at the end in this webinar. In case you have any questions, feel free to click that, and then I will try to answer the questions at the end of the webinar. And there is a video recording which will be shared with you post the webinar is complete. So you can get to see the recording of this particular webinar. A quick agenda for the day. We'll be looking at the Sumo application observability suite of solutions today. As part of the webinar, I'm actually going to show you how you can quick and effectively do troubleshooting using service maps, traces, spans, logs, etc. And we will be discussing about the global intelligence for Kubernetes. We being the global company, we have anonymized global data about all the Kubernetes deployments, similar cohort of customers, and we can show you how you can benchmark your environment against the global standards. So these are the things that we'll be discussing as part of the webinar today. The observability requires the three major pillars of logs, metrics, as well as traces. It is easy to find what is actually happening by looking at the data. It can be from your alerts, etc. So what is actually answered by things like, say, for example, metrics. It tells you what is happening. A simple example would be like, I'm running a high temperature. It tells me that what is actually happening over there. But then it does not tell me why it is happening, etc. So to get more context, if you want to move from the symptoms to why it is actually happening, you need to get more data. So this is where we will be looking into why and how, and then the where side of it. And this means that you will be looking at a sophisticated analytics tool, which can actually go through all the three pillars of your observability, which is your logs, your metrics, as well as your traces. And in today's webinar, we will see how we can leverage all this to do efficient monitoring as well as troubleshooting and get to the issues pretty quicker. What I'm showing you now is the Sumo collection diagram. We have methods by which we can collect data from almost everywhere. So we have installed collectors and hosted collectors through which we can collect data. Installed collector is a small agent from Sumo. This agent can be installed on Windows, Unix, Linux, EC2 sort of appliances. What the installed collector does is it collects data in the form of logs. These logs can be application logs, performance logs, it can be audit logs, it can be any logs. We also collect metrics as part of the installed collector. The metrics can be like CPU utilization, memory utilization, data in, data out, disk utilizations, etc. Once the data collector does the collection of the data in the form of logs and metrics, we do a very high level of compression. And once the data is compressed, we send the data to Sumo. So while transmitting the data to Sumo, use HTTP STLS 1.2 standards. So your data in transit is completely encrypted and it is completely secure. And once the data reaches Sumo, we again encrypt it with the AES-256 based standards, and we keep rotating the keys on a periodical basis. So your data in transit as well as your rest, is completely encrypted and secure with Sumo. We also use hosted collectors as a mechanism to collect data from cloud environments like AWS, Azure, GCP, etc. We are born out of AWS. We have very deep integrations with AWS. For example, if your data is in an S3 bucket, then all that we need is here read-only sort of permissions to look into S3 bucket. We keep looking at your S3 bucket. The moment we see the data, we collect it and then we ingest it to Sumo. Similarly, we can collect data from your CloudWatch logs as well as your CloudWatch metrics, etc. Similarly, we can collect data from Azure, GCP as well, though this assures you that the platform supports multi-cloud deployments for future. We have well-established data collection mechanisms to collect data from all the three major public clouds, AWS, Azure, and GCP. Similarly, we can collect data from CDNs like Fastly, Akamai, Cloudflare, etc. And we have mechanisms to collect data from your DevOps tools like GitHub, PagerDuty, Jira using webhooks. And we have support SaaS platforms like Office 365, Salesforce, G Suite, etc. We also support collection of data from your microservices-based environments, containers, Kubernetes, etc. We have a full-fledged solution for that. All that this particular diagram shows is that we can collect data pretty much from everywhere. In my few years of experience with Sumo, I have not seen any place where we are not able to collect data. You tell us where your data is, we will provide a mechanism by which we can actually collect data from your environment. Once we collect the data from your environment, the observability part begins. we have built a solution for keeping DevOps engineers like you in mind. We provide a very user-friendly interface, and the language is a easy to use language. We call this a Sumo query language. Using this, you can query your data. You can run cross correlation queries, and this pretty much simplifies onboarding of data, writing queries, and then start visualizing the data. To make the data visualization easier, we provide a lot of out-of-the-box content. We have hundreds of applications which are built by Sumo Logic, which are supported by Sumo Logic, and these are completely free. So you can make use of this out-of-the-box applications. All that is required is that you collect data into the Sumo Logic platform, and you deploy this out-of-the-box applications on top of your data, and then all the dashboards, queries, etc., they populate with your data. It is as simple as just bringing in data and then deploying the application on top of that. We also have mechanisms of auto discovery for discovering microservices. So it keeps pace with all the rapid changes which are happening across your microservice infrastructure, Kubernetes clusters, etc. For visualization and exploration, we have built numerous capabilities within the platform. You can visualize the various dependencies across your infrastructure elements, which will basically accelerate your investigation. So we have a mechanism by which you can easily pivot between the three pillars of observability: the logs, the metrics, and the traces. As part of the webinar today, we will see how we can easily pivot between the various different pillars of observability, so you can accelerate your investigation and then resolve issues faster. You can correlate among multiple data sources. You can correlate data from microservices, traces, infrastructure. You can easily pivot between all of them. And you can intuitively drill down to take a deeper view. You start at a higher level overview, then you can start going one level deeper, and you can start drilling down further to understand why your particular application is facing down, etc. So we help you to completely visualize your data as well as explore your data sets. We have applied analytics. We have anomaly detection capabilities using which you can identify any anomalous events which are happening in your infrastructure. This can be for your error logs, or this can be for your infrastructure, etc. We provide you a unified search across the logs, traces. So the interface looks similar. You can actually do your deep searches, and then you can detect what is actually causing problems for your infrastructure and applications. We provide machine learning powered workflows, which actually drives you faster resolution. We have root cause explorer. We have multiple mechanisms by which we can help you to quickly look into your data, and then you can look at very fast resolution. We have benchmarking and optimization. As a next generation machine data analytics platform, we have thousands of customers who are in Sumo Logic platform. So we have anonymized data of this particular customers, and we can actually compare your environment against this global cohort of customers, and we can tell you where your environment is stacked up against the global standards. So this helps you with respect to things like getting actionable recommendations, like 80% of cases is either actually under provisioned, over provisioned, etc. So then you can tune your environment as per your needs. Having said that, let's get into a live demo now. So what I have for the demo today here is a Sumo Coffee Maker dashboard over here. The coffee maker is something like any other coffee machine that we see. What is important about this coffee maker is that this particular application, the demo application, is built out of microservices, and you can see a dashboard over here, and I can see the visitors over time. People come here and then order things like coffee, water bottles, any snacks, etc., whatever they want, right? So you can see the data, like how many number of visitors are actually accessing it, the visitor platforms, what platforms that they access it from, application and infrastructure owners. You can see all of them, the contact details, etc. Booking split over time. So this shows what people are actually ordering over every period of time. So this gives you a breakup of various different services or products being ordered. Bookings per hour. This shows how many bookings are actually happening, like the speedometer sort of stuff. And then the booking split shows what type of services are actually my customers are actually ordering. You can also see critical metrics over here: orders over time, orders by dollars. You can slice and dice your data as per your needs, and you can see latency in orders, and it shows the duration as well as the various different transactions. And here I can see interesting panel, which is an order outlier. The outlier basically shows any anomalous events which happen inside your infrastructure. Here I'm looking at the anomaly detection capabilities over here. I'm looking at the number of orders. Here I can see at some points the number of orders actually dropping down significantly compared to the trend. And the pink triangles that you see are nothing but outliers. The outlier basically tells us the data point that we see here is actually not conforming to the trend that we see inside the infrastructure. So I can actually create alerts based on the anomaly detections. So whenever I set up static thresholds, these can easily get breached because the nature of our traffic is very dynamic. We can have more traffic in the morning, we have less traffic in the evening, or it can be for a travel company, the number of hits may be high on the weekends, number of hits may be low on the weekdays, etc. So static thresholds can easily get breached, whereas when you use a dynamic detection functionality like outlier functionality provided by Sumo Logic, so these threats will not be identified based on the static thresholds. We look at your pattern, and whenever we see there is a deviation from the pattern, then we will be basically alerting you, and you can tune multiple parameters to suit your specific environment. So from here, I can actually go into my summary. I can look at all my logs. I can go to my error logs. Just by clicking this, I can go to my logs, my error signatures, etc. And I can also go to my various different entities. And here I can see the various entities over here. I have a machine service, which is actually a container. I can see the CPU usage, memory usage, crash loop backup, etc. Everything actually being shown over here. And I can also see things, options like I can open it in an entity dashboard. I can go to my logs. I can go to traces, metrics, etc. So you can easily pivot between logs, metrics, traces, to understand why your application is actually facing problems. Here I can see that my machine services container over here, it is part of this particular pod, and I can actually see this is part of my deployment over here. I can see the coffee bar namespace, this part of a node, service, cluster, etc. I can see all of them, and everywhere I get the option to drill down further. I can move into any of these particular entities for quicker troubleshooting, quicker resolution of issues, etc. So let me look at this particular deployment over here, which will give me a higher picture. So I'm going to open it in my entity dashboard. And here you can see the Explorer-based view, which is very similar to the way of like a Windows Explorer sort of a stuff. And here I can see my deployment over here. This app is hosted out of my Kubernetes, so I can see the deployment, namespace, clusters, etc. Let me go to the cluster summary. Here I can see my coffee bar application over here. I can see my cluster overview, which shows me a lot of interesting metrics, which shows the health of my particular cluster. And coming down, I can see errors by namespace, top 10 security rules triggered, etc. And I can go to various different namespaces, and the status of those are actually shown over here. Here there's in the namespace cube system, there seems to be some pod which is actually facing issues, and that is actually shown over red using the honeycomb views, etc. There's a lot of metrics that we collect, which helps to show the status of the cluster. And from here, actually, I can go to my different namespaces. The moment I choose a namespace, I can actually see the details about my namespace over here. So like this, I can easily navigate between various different hierarchies within my Kubernetes cluster. And here, I can actually go ahead and then look at my any other namespaces that I have. I have the coffee bar app over here. There's a namespace. I can also go into other dashboards, other entities, etc. But since I want to see details about applications, I'm going to application service view. So here, I can actually see my details about my applications. Here I can see there are two applications over here, a default application, the coffee bar app. I would like to know more details about my coffee bar app. So I'm actually going into my coffee bar app over here. And here I can see various metrics which shows the health of my coffee bar app. I can see the latencies which are actually shown over in a honeycomb. Just by hovering my mouse on top of it, I can actually look at what is the utilization, what is the trend of the latency over there. And I can also see things like my requests per second over here, error percentages. I can observe all of them. Similarly, I can look at my application details. I can see the latency, errors percentage, requests per second, etc. And I can also see the latency over here, latency, service latency in milliseconds. And I can see a couple of services showing a spike with respect to latency, including the coffee machine app. And I can see the number of requests per second, errors per second, etc. This gives me information about my application, the health of my application, etc. I would like to take a closer look at my coffee machine, which is showing a spike in the latency. You can see the average latency over here, and I can see the spikes. I can see the average requests, average errors, etc. And I can also see this spike with respect to the latency, which is actually being shown over here. Right, and then the request per second, which is actually shown for this particular coffee machine service. I can also do another thing where I can move into my service maps. So using my service map, I can actually find out more details about this particular application over here. And this is a service map which shows various different dependencies between the various elements within my application. You can see filtering options over here. I can go to the Coffee Bar app, which is of interest for me now. And I can actually do some more filtering based on service names, etc. I also have an option to hide the remote services. If want, I can actually see all my services, etc. I'm going to hide all my remote services. You can also see other interesting options over here. We are actually doing an automatic anomaly detection. And if you want, you can actually modify all of this, etc. Here you can see the red one showing anomaly over here. And I see there are a couple of elements within my application which is actually facing an anomaly. I can see the coffee bar over here. It is actually experiencing a very high level of latency with high number of requests and the error percentages, etc. I also see the automatic dependencies or the transactions between my various different services. The Coffee Bar app is talking to the cache disk, which in turn is talking to a calculator service. I also see the Coffee Bar app talking to the coffee machine, which in turn talks to coffee service, etc. So I can easily identify all those different dependencies, relationships, etc. just by looking at the service map. I'm looking at the Coffee Bar app, which is of interest for me. And then from here, I can actually open it in any of these views. I can go to my logs to search it. I can go to metrics, etc. But then I want to take a deeper look at what is happening within this application. So I'm opening up the traces over here. And here I can see the traces. I can see the application. I can see the service, which is auto-filled for me. And I can choose my duration. You can see the duration is auto-filled for me. And here, I would like to see the traces where I'm actually facing errors. So I am actually looking at the number of errors over here. Whichever has number of errors which is actually greater than 0, which should be of interest to me. So I can filter out all my data. Now I can see the data is actually getting filtered out, and then I can see the traces which have errors which are actually greater than 0. And I can see the various different bars over here. Hovering my mouse on top of it, I can see the various different elements within my application, which is actually shown as part of this traces. All the interrelationships, all the transactions between the various different entities is actually shown over here. I can actually open up one of them to see what is actually happening. So I'm going to open up one of these traces over here. And here I can see my details about the trace. I can see the critical path contribution by every service over here, all my different services, how much time is taken by all of my services over here. And I can also see the various different time durations taken by various different elements within my transaction. You can see there is a order, there's a HTTP post request, etc. And I can choose to see only my error spans over here. So I can go ahead and I can enable it. And now I can see the spans with all the errors are actually shown up with a red bar over here. And I can see my various different latencies, etc. for this entire trace. So I want to take a closer look as to why this particular trace is actually facing errors. And I can drill down further. I can see the HTTP client making a request to coffee. This is going to HTTP post, which in turn is actually going into my HTTP post going to my client. And this is a place where it seems to be getting into an error. So from here, I can actually see all the details about my entity over here, like my span ID, what is my trace ID. If I want, I can copy it for further troubleshooting. I can see the service operation. There's a lot of metadata that we collect as part of the data collection. So you can use all of them to add additional context to your troubleshooting, etc. You can see this being from Kubernetes. There is a lot of metadata that we collect, which helps to add rich context to my troubleshooting efforts. So I'm going to summary over here, and I can actually look into my traces. I can go into my spans, etc. I'm actually going to get into my trace over here, my span over here, and this is taking me to my search interface for logs. And here I can actually see the log message over here. It shows that there is a received order for a coffee grains. and then we can see there is lack of coffee grains. So that is the reason why this particular transaction is actually failing for the customer. Similarly, I can actually look at a couple of other traces over here, which will show me why my trace is actually facing issues. I can actually go into, say, the other trace over here. And again, it shows me all the details. It looks at the coffee bar app, and then I can see the contribution by service for the critical path. I see the coffee bar app over here, and again see there are a lot of errors. And let me take a closer look at it. I can see get coffee. It looks like the customer is ordering a coffee over here, and it seems to be failing somewhere around get water. So I can go back to my logs. The logs tell us why the particular problem is actually happening. So I can get into my detailed drill down from my traces to the logs just by hovering over the hierarchy. I can see received order for water in amount, and then there is not enough water, right? So because of that, the trace is actually failing. So the customer transaction is actually failing. So like this, I can actually make use of the traces. I can go through in depth, and I can find out why the problems are actually happening with respect to my application. So I can easily pivot between the metrics, which shows what is happening. And from there, I can actually get into my logs and traces, which tells me why the specific issue is actually happening. I can also go to my span views over here. This is my span view. And here I can actually start looking out for things like, say, for example, service. And I can look out for the related service over here. I'm looking at, say, for example, the cache disk, which is actually interacting with my service. So I can choose the cache disk over here. And then the duration, I can look at my average latencies over here. And then I can look at things like, say, for example, the duration. I can, yeah, we already chose the duration. We can look at the time, and maybe I can group it by 1 minute, 5 minute, 10-minute intervals. And then finally, I can also look at my HTTP status codes. So, and I can ask my system to actually start searching for this. Now here you can see the similar sort of interface which comes up. I can actually look into all my traces, and I can actually query them like how I do my log searches over here. And I can do all my aggregates over here. I think my internet is actually running a bit slow over here. So what I can do is that I can open it in a search, the way I used to do my searches. And here I can see, I can actually query it, or I can actually search it like how I used to search my logs. And here I can see all my visualizations over here, which shows my various different status codes and then the various different latencies, etc. Right? So you can query your traces, and then you can build all your visualizations, etc., using the Sumo Logic interface. So having seen that, let's get back to our demo over here. We have a mechanism by which we can provide you greater intelligence, a global intelligence for the Kubernetes as a service. So we have an sample application over here where there is a load balancer, which is front-ending the application, talks to a payment service, which in turn talks to the account service. There in between, you have a couple of pods, which are part of a deployment, and talks to the database in the backend. So when you have apps like this, you generally be provisioning memory, CPU limits for your various different services. What we see is that if you are doing an over provisioning, then there is a risk that the capacity remains unutilized and you are actually overpaying for it. And here you can see, if you set up your limits very high and your usage is actually far below that, then you are actually wasting resources. And if you are actually setting up aggressive limits, there is a possibility that your applications are actually facing availability issues, because the cluster is actually going to go and kill it because your request is actually crossing over the limits. So while under provisioning actually helps with respect to saving the resources, money, etc., the possibility of the services getting affected is actually very high. So this is a place where we can actually help customers like you. So we have a global intelligence for Kubernetes. So we look at the global anonymous stats. We look at similar cohort of customers. We can help you to compare and benchmark your environment against the global standards. So here you can see the Kubernetes adoption stats. And here you can see yesterday to today, the cluster count, my company versus the benchmark. So here you can see the benchmark. This is against your company. How many clusters generally we see across global customers? And then you seem to be having 3. Similarly, you can see the deployments across the anonymized data. You can see all those global benchmarking data over here. And from here, I can actually get onto my summary. So this is my summary for the Kubernetes deployment. So here I can see, I can actually look at 100% of my history, or I can actually look at 50%. We suggest to look at all of your history so that we can provide you better, I would say, data with respect to the global intelligence. You can see the cost optimized one, you can see the balanced optimized, or the reliability optimized. So you can see all those different parameters over here. And you can see the same thing for your CPU as well as your memories. So this is where we can actually provide you an action plan, where we can actually provide you recommendations. Say, for example, this is the action plan for the Kubernetes CPU. So you can actually decide, say, for example, the container CPU request, current versus recommended. You can see the current one, you can see the recommended one. So this is based on the data that we read from your environment. And you can see the reliability optimized, cost optimized, balance optimized, all the three different options that you can actually have. So you can go to any of the method. I'm actually looking at the balanced method. I can actually also look at high reliability is more important for me. In that case, I can choose my high reliability, and then you can get the recommendations based on that for the high reliability. Or I can say that cost is actually important for me, and I can actually run my my queries based on the cost. So this will be showing you the cost recommendations. So you can see the current one versus what is a Sumo recommendation methods over here. So by this, you can tune your environment, and then you can set up your environment, because manually deciding these levels is going to be impossible, next to impossible. This is where we Sumo Logic come in, and then we can help you to recommend the right level of settings. The next dashboard I have you is similarly for the memory side of it. And you can see the various different recommendations depending upon whether you want a balanced one, or you want a cost optimized recommendations, or whether you are looking at a reliability based one. Right. So that's pretty much what I wanted to show you as part of the global intelligence. So in this curve, the idea is to be somewhere to be balanced, rather than looking at high reliability running at a very high cost, or looking at a lower cost but incurring the risk of under provisioning the resources, which results in disruptions. So we can help you to achieve a balance between these two using our global intelligence apps. So that's pretty much about what I wanted to cover as part of the webinar today. We have our Sumo Logic user conference Illuminate happening now, September 28 and 29. The APJ times are like 29 and 30. So I highly recommend you to go to the Illuminate and then register yourself. There are very interesting sessions actually happening over here. This is a location where you can actually go and then register for the service, register for the event. You can see a lot of interesting topics actually coming up over there. We have numerous breakout sessions. You can do certifications, master classes, workshops, a lot of interesting stuff happening over here. You can also try Sumo Logic for free. Click start free trial, provide your business email ID, and then choose a location where you want to keep your data. And you can choose APAC Mumbai if you want to keep your data in Mumbai, or US, anywhere. And you will get a verification email. Once you validate that, your trial account starts. You can try Sumo Logic, and let us know in case you have any issues, you want to do a focused POV. We are happy to work with you to set up a POV for you. Right, so that's pretty much what I wanted to share as part of the webinar today. Thank you for joining the webinar. Feel free to start a trial, explore the product, and if you want to buy, let us know. You can reach back to the sales guys. If you have any questions, you can come back to Sumo Dojo channel, and then we can actually help you to explore Sumo Logic as a platform. Right, so thank you for investing your time in Sumo Logic today. I wish you all a very good day.